Hey, everybody, welcome back to the Post Frame Podcast. In this four-part series, we're going to be covering why post frame construction is a smart choice for commercial buildings. This is the last one, number 4. We made it to the last one. Strength and durability.
Strength. I
Yes.
like that topic.
So, steel frame is stronger than post frame, correct?
Now, come on, TJ.
No?
Don't buy into the stuff
No?
you read online.
Okay. Prove me wrong.
Yeah. That's definitely a common misconception, right? We get that from, I'll call them the self-proclaimed engineer, right? They believe they know, okay, that material, right, is going to be stronger. Well, it's really about the application within the system that you're designing. So what I mean by that is I'll plainly answer your question. No, steel is not more stronger than wood or than a post frame design, because when you look at the entirety of the system, because in a commercial setting, everything has to meet a structural code, right? We talked about in other videos the difference between zoning and permitting and code compliance and some of that. And so every building, every commercial building, depending on its use, has to meet a structural code, right? It has to withstand so much structural fatigue, right? Wind pressure, snow pressure, interior weight of things that are hanging on it, all this stuff.
So, could some of those buildings almost be like, you have to build this steel frame depending on what code?
No.
Or does that not matter?
No.
No? Okay.
No. The code is not going to dictate what materials you build it out of. They're just going to dictate what it has to withstand, right? What pressures that structure has to withstand. And so whether you use wood or steel, you're still
you just have to meet code.
You just have to meet that number, right? That wind load, pressure, whatever it may be. Post frame buildings, generally around 8 foot on center, you're going to generally see bigger wood members, 2x6s, 2x8s, 2x10s, 2x12s, very different than stick frame, mostly 2x4s. So you're going to have some bigger members, spaced 8 foot on center. And so the structural design takes into account that column spacing, that truss spacing, integrates then wall framing spacing, roof framing spacing, and then a lot of the connection points, right, where your truss connects with your column, right? How your steel connects to the structure itself. And all of that provides, we call it diaphragm strength, to keep that building from racking, tweaking, essentially failing under the pressures. What's different then in steel frame is your system just changes. You're 20, 25, 30 foot on center with your columns. You're much further apart. Your wall framing is a different spacing. Could be 3 or 4 feet on center versus 2 feet to 30 inches on center. So no, steel frame is not stronger. Both designs are aiming and needing to meet a specific structural code, and we just get there from different pathways.
Okay.
So you're not going to feel, you shouldn't feel any safer, right? Thinking that I'm standing in my steel frame building, I'm better off, because it has no more structural. It's not like every steel frame building goes 50% more beyond the code, right? And a wood frame building gets right up to it, or maybe less, right? And so if you pull at the assumptions that maybe are behind some of those misconceptions, they start to show that, okay, that's not actually going to be true, right? A steel frame building is not just going to inherently design itself to be way beyond code, and post frame not, right? They're both going to end at meeting that code as necessary for the type of building it is. So anyways, the last thing I want to talk about, strength and durability, is probably just the overarching nature of quality. Mm-hmm. Steel frame, you could have disconnected entities doing a lot of different parts of the process. You could have a structural designer or engineer that's designing this thing that is a standalone entity or company. You then could have a material supplier who's, molding and making the steel members and shipping them out to the job site. And then you could have a different person who's actually erecting that structure. And you have a different contractor who's laying the foundation. So you have 4 different entities at least when you go, that you have to make sure all are coordinated well. The design matches what was made, that then when you get on the job site, your foundation and where the anchor bolts and all that stuff's at all marry up so that that goes well. With post frame, you're generally much more vertically integrated than that. Not everybody does everything in our industry, but FBI, we have structural engineers who are designing the structure. We build our own trusses and columns and roof framing and wall framing and all that. We make it and ship it out. And then our crews are who builds it. And so from front to back, you have some quality assurance in that is a unified chain versus disconnected ones that you got to make sure all match up.
Right.
So some differences there as well.
All right, Blair, that's going to do it for this series. Appreciate you stopping by again. I know I missed you on the last podcast.
It's all right.
I'm
It's
glad,
all right. We got to spread the wealth around.
We do. I'm glad you're back in the seat.
Hey, thanks, buddy.